Before moving to the convergence of bounded sequence using limit superior and limit inferior, let's determine the limit superior and inferior of the following sequences here. Let's start with x sub n being 1 over n. As mentioned in the definition in the previous video, limit superior is the infimum of a certain set V containing real numbers V. Okay, so let's try to come up with the sequence of this. So when n is 1, that's 1. When n is 2, 1 half. When n is 3, 1 third. When n is 4, 1 fourth. When n is 5, 1 fifth. And you will have here 1 sixth, and so on and so forth. Now, one process I have learned is to come up with a supremum of a certain sets using the elements of the sequence. Let's say the first supremum is the supremum of this set of elements from the sequence. You have 1, 1 half, 1 third, 1 fourth, 1 fifth, and so on and so forth. Okay? The supremum of this, as we know, supremum is the least upper bound or the least maximum value. So we have here 1, as this is the least upper bound of this certain set. Now, let's have another supremum here, but in this case, I'm going to use the second onwards, okay? Not considering the first element of the sequence. So I have here 1 half, 1 third, 1 fourth, 1 fifth. Of course, we have 1 sixth, and so on and so forth. The supremum of this, as mentioned, is the least upper bound. That is actually 1 half. Okay, this is the least upper bound of all the elements of this sequence. If I may continue, I would have 1 third, 1 fourth, 1 fifth, 1 sixth. Of course, we know that 1 over 7 as we continue forward. The supremum of this, or the least upper bound, is 1 third. Okay, if you would like to continue for the fourth one, so we have 1 fourth, 1 fifth, 1 sixth, 1 seventh, you have 1 eighth, okay, and so on and so forth. The least upper bound of this is actually 1 fourth. Okay, if you would like to continue with the rest, let's say s sub n, okay, we'll get here the supremum. Of course, you will get a values of 1 over n, and you have here 1 over n plus 1, 1 over n plus 2. As you will start with 1 over n, this is actually equal to 1 over n as well, the supremum of that. Now, collecting all of this, that is our set V. Set V, okay, is a set containing all of this. You have 1, 1 half, 1 thirds, 1 fourth, until 1 over n. Okay? Now, the limit superior of x sub n is equal to the infimum of this set. Okay? 1, 1 half, 1 third, 1 fourth, until 1 over n. That is the idea here. It's the infimum of this set. And we know that infimum is the greatest lower bound, okay, the greatest lower bound of this, okay? And the greatest lower bound of this is actually the limit of 1 over n as n approaches infinity, which is equal to 0. In short, the limit superior of our given x sub n, which is identified as 1 over n, is equal to 0. This is the infimum of the set V for all V element of real numbers following this idea. Okay, now, after the limit superior, which is the infimum of set V, we can also identify here the limit inferior of x sub n. The limit inferior of x sub n is the supremum, okay? Supremum of all situations like this. So we are going to come up with the infimum of all. So if we're going to have, let's use I, okay? Again, our x sub n is, we have 1, 1 half, 1 third, 1 fourth, 1 fifth, and so on and so forth. So let's have I sub 1, which is the infimum of the entire here, 1, 1/2. Let me use this bracket so that it be similar. 1, 1/2, 1/3, 1/4, 1/5, and so on and so forth. The infimum of that is the greatest lower bound. The greatest lower bound for this is actually equal to 0. Okay, the greatest lower bound. Right? As of course, this is the limit of your 1 over n as n approaches infinity. Okay, if we're going to use the second element onwards, the infimum of that, 1/2, 1/3, 1/4, 1/5, and so on and so forth, is still 0. Okay, the greatest lower bound. If we have the third one, the infimum of that, starting with 1/3, 1/4, 1/5, 1/6, and so on and so forth, it's still 0. If we're going to continue to the nth infimum, we have here 1 over n, 1 over n plus 1, 1 over n plus 2, and so on and so forth. This is still 0. So our set V here is a set containing 0, 0, 0, dot, 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 0 as well. And the limit inferior of your sequence is the supremum. Okay? The supremum of your V, set V here. The supremum of that is the least upper bound, and it's actually 0 as well. So we have identified here that the limit superior and the limit inferior are of the same value, 0. And we have a what do you call this one, implication to that, to the convergence of the bounded sequence. We will have that on a separate video. We will have more examples on identifying or illustrating limit superior and limit inferior. Thank you very much for watching.